Figures 11.9 through 11.11, Case Study, String Class. Now, as you know, the C++ standard library already has a string class. So what we're doing this example for is to introduce some other key overloaded operators and techniques, as well as another special type of constructor, which is known as a conversion constructor, which allows you to convert a value of one type to an object of a class. And we're going to do that with our own string class. Now, much of what we have in this string class is very similar to the array case study. So rather than going through all of that again, what we're going to be doing here is focusing on the things that are special about our string class. Now, first let's take a look at our main program, see how we use our class string, take a look at the various overloaded operators, then we'll take a look at the header file to show you the declarations of the member functions, and then we'll take a look at the details of a few of those member functions to show you how they are implemented. So let's go ahead and run this program. And these warnings you can ignore. These are Visual C++ specific warnings here. So we'll take a look at this output as we go through the source code. So here in main, we start by creating a couple of our string objects. And in lines 12 and 13, we're calling the constructor which receives as its argument a C-style string. And these are examples of the so-called conversion constructor. A C-style string is implemented as a character array, and basically what we want to do is convert these underlying character arrays that represent the string literals happy and space birthday into string objects, which we're going to call S1 and S2. And then we also have a call to whichever one is the default constructor to initialize the string S3 with the empty string. And the next thing we do here at lines 17 and 18 is output the contents of those three strings in quotes so that you can see that, yes, here we go. So we have calls to the conversion and default constructor, and then we have S1 is happy, S2 is birthday, and S3 is the empty string. Now, one of the things we've done in this example is show you when the constructor, the conversion constructor, is being called so that you can see cases where it gets called for you implicitly in the program's output. And of course, you typically would not put output into a constructor. The reason we do that is for pedagogic purposes. Now, the next thing we want to demonstrate to you is the ability to compare strings. Now, with C-style strings, you can't compare them directly because they're just pointers or arrays, but you can use the C string header files C functions for comparing string values. And so you have things like the strcmp function that is capable of comparing C-style strings. But you don't have the ability to do that with operators like you would like to do in C++. So we built into our string class, and the designers of the standard template library version of the string class as well built into their version overloaded operators that represent the relational and equality operators. So I can compare two string objects to see if they're equal, not equal, to see if they're greater than or less than one another, and this will be what we call a lexicographical comparison, and also to see if they're greater than or equal to or less than or equal to one another as well. And as you'll see, we're going to implement those using some of the C standard library header file functions that are part of the C++ standard library as well. So if we stop there and take a look at our output, we can see that S2, which is space birthday, and is not equal to S1, which is happy. So double equals returns false, and not equals returns true. S2 is greater than S1 yields false. Well, S2 starts with a space. S1 starts with the letter H, and the space character's underlying ASCII value is smaller than that of the lowercase h, therefore that is false, and therefore S2 less than S1 yields true. And of course, the greater than or equal to yields false, and less than or equal to yields true as well. So we can do our comparisons. We also have a use of the unary operator not, and basically what we're saying here is that we're going to test this not operator to see if a string is empty. So if not S3, if the string is empty, if it does not contain any data, then we're going to say that it's empty, and we're going to assign S1 to S3 and then display the contents of S3 for you. So you can see that S3 is indeed empty, and that we're assigning. We can see that the operator assignment was called, and we're again outputting there so you can see when this gets called. And finally, we show you the contents of the object S3. Next, we're going to use the plus equals operator to implement string concatenation. So here you can see S1 plus equals S2, and what we want to do is take the contents of the string S2 and add them to the end of the string S1 and store the results in the string S1. And when we're done, that means that S1 should contain happy space birthday. So if we stop there, you can see that when we do that, indeed S1 is now happy birthday. Now this is interesting. S1 plus equals the C style string, the string literal, space 2U. Now, there is no version of the plus equals overloaded operator in this example that receives a C style string. In fact, if we go to the header file right now, you can see the only plus equals operator that we define expects to receive a constant string reference. But because we have this concept called a conversion constructor, let's go back to main here, we can actually take a character pointer based string and add it to a string object, and what's going to happen here is C++ is allowed to implicitly convert a value to an object type once in an expression. So we have a conversion constructor that expects to receive a C-style character string and can turn it into a string object, and what happens here first is that it creates a temporary string object containing 2U. Then it calls the plus equals operator that takes a string object as an argument and adds it to another string object to produce the final result. And after this, that S1 is going to contain happy birthday to you. So where are we here? Here we go. Here's S1 happy birthday to you. And you can see that there was a conversion constructor call and a destructor call for the string to you. And we've got these output statements to show you that what's going on at the code level could actually be much more subtle than what's really going on behind the scenes. So you may look at this S1 plus equals 2U statement and say, oh yeah, we're adding 2U to the end of the string S1, but in reality, we are allocating a new string object, initializing it with 2U, concatenating that string object to the end of the string S1, and then destroying that temporary string object. So there's a lot of overhead behind the scenes of this plus equals operator. However, at the same time, you get the convenience of being able to add a C-style string to one of our string class objects. And you can do the same thing with the built-in string class as well. The next thing we decided to do was show you how to overload the parentheses operator, which is also called the function call operator. And the interesting thing about this operator is it can be overloaded to have any number of parameters, just like a function can have any number of parameters. So here what we're doing is using it to create substrings. So when you say S1 with 0 and 14 in parentheses, it says give me a substring of S1 that starts from index number 0 in the underlying character array, and give me 14 characters from that position. And this is going to give me the first 14 characters within S1. So if I take a look at my output, you can see that it gives me back happy birthday. Now you can see that there's a lot of stuff going on here as a result of that operation. And we'll talk about what's happening here in the output when we take a look at the overloaded plus equals operator, and also at the overloaded parentheses operator, which is the one we're looking at right now. These things have additional overhead that you need to be aware of, so we'll point out where that's coming from in the example. So here, again, the first 14 characters. Now, separately, we have this set up so that you can specify only one argument to the parentheses operator, and in that case, it takes a substring starting at the index you give it all the way to the end of the string. So it's going to give me the remainder of the string S1 starting from position 15, and in that case, it's the string 2U. Now, here at lines 59 and 60, we show you how to dynamically allocate an object of our string class. And here what we're doing is calling the copy constructor to initialize this new string with a copy of the contents of S1. So S4PTR points to a dynamically allocated string object containing the same thing as S1. And when you want to output that string object, you can do so by dereferencing the pointer, which gives you the actual object. And we've overloaded this double less than sign stream insertion operator, and we've actually used it several times now to display a string object of our string class type. And of course, the built-in string class from the standard library has that capability as well. So here we're demonstrating the copy constructor, and actually we're also demonstrating the destructor by deleting this dynamically allocated object later on. Lines 63 through 65 are testing for the overloaded assignment operator and making sure that we don't accidentally delete the data also. So here, excuse me, we can see that when we initialize the object that S4 pointer points to, it contains happy birthday to you. We can see when the assignment operator is being called, we can see that there was an attempted self-assignment, and that the object still contains the string happy birthday to you. And then when we delete the object, we get the destructor call. And then finally, we wanted to demonstrate our square brackets operators. So here we're using them for L values to change the value at position 0 to the capital H and the value at position 6 to capital B. After doing that, the string S1 is going to contain happy birthday with capital H and capital B, as you can see here. And then finally, we wanted to demonstrate trying to access a subscript out of range, and as we did in our array class, we set it up to terminate the program if in fact we access an element that's out of range, and we also display an error message as well, which you can see here at the end of the output. Now, the next thing we're going to do is start to take a look at the implementation of our string class. So let's go back to the header file. You can see that once again we're using the IOStream header files OStream and iStream types, which we use with our overloaded output and input operators respectively. Here at lines 12 and 13, you can see our friend overloaded output and input operators, and the basic concepts here are the same as what we did in the array class that we looked at in the previous video of this lesson, so we're not going to focus on those here. We are, however, going to take a look at some of the other member functions that are built into class string. Starting with line 15, which is our first conversion constructor. It turns out that any constructor that takes one parameter by default is considered to be a conversion constructor that converts a value of that parameter type to an object of the class type that's being constructed. Now in our case, we're receiving as an argument a constant character pointer with the default value of the empty string. And basically we're saying that we want to be able to take a C-style string and convert it into a string object, copy it into a string object. This is also the default constructor because it can be called with no arguments. We have a copy constructor, and again, this class is going to do dynamic memory allocation, so we're going to have a copy constructor, a destructor, and an overloaded assignment operator so that we can properly copy, assign, and destroy string objects in our program. We've got our overloaded assignment and addition assignment operators, which we're using for concatenation. We have our first unary operator, which when you implement it as a member function has no parameters, because remember, an operator overload for a member function has an implicit argument, which is the object that calls the function. In the case of a binary operator, that's the left operand. In the case of a unary operator, that's the only operand, the one that calls the function. And this is a const member function because it doesn't modify the object when testing to see if the string is empty. We have overloaded double equals and less than operators, and it turns out that if you have these two operators, all of the other relational and equality operators can be implemented in terms of these two operators. So we know, for example, if you have an equals operator, that you can implement the not equals operator in terms of the equals operator. So here's the not equals, simply returning the opposite of what the equals operator returns. And if I have a greater than, a less than operator, then I can implement the greater than operator in terms of less than. And the way that I can do that, if the left operand is less than the right operand, then the right operand is greater than the left operand. Similarly, so if you see here the greater than operator here, basically we're saying to implement greater, check to see if the right operand is less than the left operand. What do I mean by that? Well, initially, let's say we have string objects hello and there. So hello is on the left side, there is on the right side. Hello is less than there because H is less than T in the ASCII character set. I'm assuming the same cases, by the way. So if the one on the left side is less than the one on the right side is greater than the one on the left side. So basically, by reversing the operands, you can take advantage of an existing operator that knows how to do a comparison, and that's what we're doing here. Now, in the case of less than or equal to, what we're doing is we're reversing the operands first, and then applying the not operator here as well. So if I want to know if the left operand is less than or equal to the right operand, first I'm going to check to see if the right operand is less than the left operand, and then I'm going to apply the not operator to that, and that gives me the equivalent of the less than or equal to operator. And I do similar thing here for the greater than or equal to operator as well. If star this is less than the right operand, then simply returning the opposite of that tells me what the value for greater than or equal to should be. So it's very common, by the way, to have lots of overloaded operators in a class, and to have them implemented in terms of other overloaded operators in the same class. And when you're doing that, it's very common to define those operator functions that are implemented in terms of other ones in the header file within the curly braces of the class, so that you get implicit inlining of those member functions. And then finally, we have a few other pieces for our class string. We've got two different versions of the square brackets operator to deal with non-constant uses and constant uses. We have our overloaded parentheses operator, which in its parameter list in this case has two parameters, one of which has a default value of 0. And when the default value of 0 is used as the second argument, it says give me all the way to the end of the string. And we have a getLength member function, so all of our strings know their own length, whereas built-in strings of the C-style variety, pointer-based strings, do not. Of course, the string class that's built into the standard library has the capability of knowing its own size. Our private data consists of a length and a character pointer that points to the underlying dynamically allocated character array, which we'll use to represent our string. And then we have a utility function called setString, which is used by a few of the member functions. So finally, let's take a look at some of our member function implementation details. By the way, notice that we're using some C string header file functions. These are from the C standard library included in C++. strcmp allows me to compare C-style strings. strcpy allows me to copy C-style strings. And strcat allows me to concatenate C-style strings. So let's take a look at our constructors. Our conversion constructor is going to convert an existing C-style string into a C++ string class object of our string class. And we're initializing in the member initializer list the length piece of data, which says how long our string object is in terms of number of characters. First, we check the current string that's received as an argument to see if it's not equal to the null pointer. If it's a null pointer, there is no string to copy. So in that case, we're going to set the string length for our string to 0 because it's an empty string as far as we're concerned. So if you give me a null pointer representing a character pointer, then I'm going to say create an empty string object. Otherwise, I'm going to use the length of the C-style string as the value for my length piece of data. I'm also going to show you that the conversion constructor got called for pedagogic purposes, and then I'm going to call setString with the argument s to allocate the dynamic memory for the string object and to copy the contents of s into that dynamic memory. Now, the copy constructor is very similar. It receives a reference to an existing string object, string class object. It uses that string object's length member to initialize the new string object's length member. I show you that the copy constructor got called for pedagogic purposes, and I call setString to copy the underlying C-style string of the copy object into the one that's being initialized. And of course, my destructor, I'm showing you that it got called and deleting the dynamic memory. The overloaded assignment operator is very similar in concept to what we did with the array class, except to do the dynamic memory allocation and copying, we call setString our utility function for that purpose. Here at line 62 through 74, we have our overloaded plus equals concatenation operator. So let's look carefully at what's really going on with this operator. It expects to receive as its argument a reference to a string object. So when we pass in a string object by saying string s1 plus equals s2, it's going to just refer to that second string object. But when I say to call this by passing in a C-style string, first the conversion constructor will get called to create a temporary string object. Then the temporary object will be passed into this operator plus equals function and used inside the function. So what we're doing for the concatenation operator is we're adding our lengths together. So the new length is going to be the addition of the two lengths of the two separate strings. For the underlying character array, we have to allocate that length plus 1 because we need a terminating null character for the underlying C-style string. We assign that to temp PTR. We use the C-style string copy function to copy the original object's string into the new underlying character array, and then we copy from that temp PTR plus length position. Plus length says at the end of what was just copied in, I want to now, start copying in the right-hand side's data, and we copy from the right-hand side's underlying character array. Then we delete the left-hand string object's original dynamically allocated memory, and we assign the new dynamically allocated memory to our private data. We assign the new length to our original length, and we return our string object. So we copy the original left side's data into the new dynamic array. We copy the original right side's data to the end of that new dynamic array, delete the old data, and put the new data into the object. The not equals operator is pretty straightforward. Just return length equal to 0. If that's true, then the string is empty. The double equals operator and the less than operator are simply using the C-style string compare function, which returns a negative number if the first operand is less than, if the first argument, is less than the second argument, 0 if they're equal, and a positive number if the first is greater than the second. So if they're equal to 0, if the result is equal to 0, then this is indicating that the underlying strings are equal. For the less than operator, we test less than 0 because if the first is less than the second, then the result will be less than 0. If that's true, then the first string is less than the second one. And again, all the other relational inequality operators are implemented based on these. The square brackets operators are very similar to what we did in the array class. In fact, they're identical to what we did in the array class. They're just being implemented for class string now. And then finally, our overloaded parentheses operator in terms of the new operator overloading features. What we're doing here is we're going to get a substring out of our string object. So let's see how we do that. We receive two parameters, the index that we want to start copying from and the number of characters to copy. Now if the index is less than 0, if the index is greater than or equal to length, or if the sublength is less than 0, in all of those cases, we are going to say that these are invalid values, and we're just going to return an empty string. Now, look at how we're doing that. We're returning the string literal that contains no characters from a function that returns a copy of a string object. So what happens here is the conversion constructor gets called. That results in the creation of a temporary string object containing the empty string. We then return that object by value, so the copy constructor gets called to copy that string in the client code. Then the temporary object that was created by the conversion constructor goes out of scope and gets destroyed, and then eventually the one that was returned back to the caller will go out of scope and get destroyed as well. So there's a bunch of overhead that you don't necessarily think of when you're just looking at the code here. Now, assuming that we don't return the empty string, we then create a local variable length, and we're going to determine our substring length. If the substring length is equal to 0, or the index of the starting position plus the substring length is greater than the length of the string, then we'll perform this calculation to determine the length. Otherwise, we'll just use the supplied substring length. So we're going to figure out what number of characters we need to copy, and basically what we're looking for here is whether we need to get to the end of the original string or just use whatever number of characters that were specified. Now, the next thing we do is we create a temporary character pointer and allocate a character array to it, which is length plus 1 characters. Then we copy into that dynamically allocated character array the substring portion that we wish to use, and we null terminate that C-style string. Then we create a temporary string object, copying the contents of temp pointer into that object. That, of course, is going to call the conversion constructor because temp_ptr is a character pointer, so the conversion constructor can take that and copy the contents of the underlying C-style string. We then delete the dynamic memory that we just created up here to make sure that we properly deallocate the memory before we leave this function, and we return temp string, and again we return that by value. So we're going to get a new copy constructor call, which is going to create a new string object containing a copy of temp string. This string object is going to go out of scope, so its destructor will get called, and eventually the copy that's returned will go out of scope, and its destructor will get called as well. So again, when you're dealing with operator overloading, you have to carefully think through what's really going on, and it's helpful, by the way, to step through your program in the debugger to see when these temporary objects are being created and destroyed as well. And so even though we're providing this extra convenience of being able to do these interesting operations with overloaded operators, the combination of conversion constructors and overloaded operators can result in some very interesting extra overhead being added to your program. And of course, there's a trade-off between that extra overhead and the convenience of being able to program with these overloaded operators. Just taking a quick scan through the rest of the function or the rest of the capabilities of our class. GetLength simply returns the length. SetString is our utility function that allocates a dynamically allocated array of length plus 1 characters and then does the appropriate copying and initialization of the underlying character array. And then we have our overloaded output and input operators. In the case of the output operator, we just output the underlying C-style string, which this operator already knows how to do in the cin object or the any kind of, I'm sorry, not cin, the cout object or any kind of output object that is part of the streams library in C++. And for the input, we have kind of a limited input. We're going to only allow you to input up to 100 characters in this example, and in fact this should really say setw99 so that we save the 100th position for the terminating null character in the example. So we're going to read in a string into the temporary character array. In fact, no, I'm sorry, this should be 100 because inputting it will automatically put the terminating null character there for us, and then we're going to assign to the string s the temporary character array. This assignment is interesting. So look what we're doing here. We have a string object that we're referring to on the left and a character array on the right. So think about that for a second. Again, there are some subtle issues here. This is the assignment operator. Let's go back and look at that assignment operator. And you can see that the assignment operator doesn't expect a character array. It expects a string object to be passed by reference. So here again, we have some subtlety. What's happening is we're getting a conversion constructor call to convert this character array into a string object. Then this string object is being assigned to whatever s refers to, and then the temporary object that got created by the conversion constructor will be destroyed. So again, in C++, because of these kind of implicit conversion capabilities, there are often extra function calls happening behind the scenes. Most commonly, those function calls are conversion constructor calls that enable you to convert one value to an object type so that it can be used with a particular overloaded operator or function call parameter.